Hey everybody, this is Larry. This is day, I don't know why I look at my watch, it doesn't show me the day. But day 25 maybe? I don't know. I mean, you know the day. Of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Yeah, so I got the new iPhone. I mean, I don't know. I'm not really like one of those gadgets people, right? Tech gadgets, like show off reviews people. But people asked me in the comments because I was just like, I don't know, I mentioned it and people asked me about the camera quality. So I figured, what's a better way to show the camera quality than here? And this is the selfie camera, not the back facing camera. So you tell me how good it is in the dark, as you can see. I mean, I'm walking like in and out of the light. You can't even see the phone shadow on my body. But yeah, let me know in the comments. This the World Trade Center. Okay, the tree's actually behind me. I was like, behind me should be the World Trade, but the tree is actually right behind me. So I don't know. I do the same route basically every other day because it is just straight and flat, and I don't have to worry about people. But yeah, all right. Oh, there you go. See, isn't it nice? And also, if you want to see New Jersey, but yeah, that's my sample preview in the dark because I don't know. I'm a dark person. Or like I'm a night person. The other comment sounded a little off. But anyway, all right, that's it. See you later. Hey everybody, this is Larry. I mean, we did the intro, but just still saying hi because for me, look, for you it's a couple of seconds ago. For me, it's been a couple of hours because it's 3 a.m. I am so tired. Not gonna lie. I ran from like 10:50 to 1 a.m. Got back at like 1 a.m. or something like that. It's not very healthy, but I got my run in. Some days you just have to do it whenever you can do it, even if it is ridiculous time. And yeah, and as you saw from the video. And of course, I mean, it's a little bit later because I had to cook. And when after you work out, you want to get your carbs and your food and your protein in. So I definitely did that before working on this problem. But yeah, I'm very tired. Hope you like the camera quality. I mean, I don't know. I honestly haven't looked at it yet, so I'll probably watch it afterwards and see how it gets uploaded to YouTube with all the conversion and all these things. We'll see. It's my first video from the thing, so yeah. Cool. But so without further ado, let's get started on this problem. We have 611, valid triangle number. Okay, given an integer array nums, we know the number of triplets chosen from the array that can make triangles. We take them as side lengths of a triangle. Okay, and I think the first thing to know is, of course, this thing called triangle equality. What is the triangle equality? Did I say equality? Inequality. I don't know, remember what I said, but what I mean to say is triangle inequality. And you can probably Google this up, but it's a very straightforward thing where right? Nope, dead away. Very straightforward, but you still mess up apparently. But the idea here is that we draw a triangle, and I mean, the formula is a little, whatever, but honestly, the proofs I don't know. I think geometry proofs. I'm not very good at geometric proofs because, as a more computer dude, that doesn't really come up as much. Or like I'm just not very practicing it. But for me, I don't know if this is a hard or good proof as I try to find my pen. But it is a proof in the sense that. Yeah, I mean, it's just very visual, right? And the idea is it's very basic. If you have a line C, if you have a line A and a line B, if A plus B is less than C, then it just doesn't meet, right? I mean, it's just as straightforward as that. And if A plus B is equal to C, then they just literally meet, but you don't have a triangle, right? You just have a line or 3 lines or whatever. So A plus B greater than C, then you have this thing where you can now build a house or whatever you want to call it, a triangle. That's basically it. I mean, it's not a, it's not a, I don't know. I don't know if it's a tight mathematical proof because it's not something that I'm trained in, but I don't even know if I could call it intuitive. It's just very visual, right? You draw it once, it's hard to forget. Though apparently I still mess up this sign, but I mean, I don't know, right? So yeah, so okay. So the first thing is noting that, I don't know, there are a couple of things you can do, right? The first thing, maybe there are more things you can do, but I think, I don't know. Look, it's like I said, it's 3 a.m. I'm tired, I'm lazy. Let's just do the bare minimum, right? And the bare minimum, I can't even say minimum, is n is equal to or less than 1,000, right? Or just say 1,000 in the worst case. And if n's 1,000, n squared is going to be fast enough. I'm not thinking about anything harder than that, right? And maybe even n squared log n if you want to do that. But yeah, so what would an n squared, and then honestly, this is a little bit, I don't know if it's cheating, but it is working backwards, right? Okay, let's say n squared is good enough, and maybe even n squared log n, but let's start with n squared first, and I don't know, we'll see, right? And n squared, what does that mean? That means that for every pairs of number, count how many numbers that were, like, I mean, you could do it in either way, right? So you could iterate you have this formula AB is greater than C. So we just kind of iterate on A, iterate on B, count the number of C, and that's it. And they're probably, I mean, like I said, my brain's not working today, so my apologies. I'm just really tired. Oh, my workout today was, I don't know if I mentioned it in the earlier video because that was a couple of hours ago, but yeah, I ran 11 miles, and this is probably the fastest 11 miles I've ran in my, like in terms of that length. So I'm just like really beaten up, and it's just a workout, right? I don't know what it means other than that I'm just very tired. That's my excuse, and I'm sticking to it. But in any case, yeah. So you could iterate on A, you could iterate on B, and then you could find or count the number of C's. And there are two really general ways. I mean, I don't know if they both work. I mean, I know one of them work. The one of them, for example, is binary search, right? Because, okay, you're looking for C. If we sort the initial input, you could binary search. Straightforward things to do. Have to do some if statement so that you don't count A and B again. But, you know. But yeah, pretty straightforward, right? And then the other thing that sometimes happens, but you have to kind of make sure things align, it's a sweep line, right? Or maybe not quite sweep line, but two fingers in any case, right? Because the idea here is that when you iterate, well, A, you iterate A, but then let's say B, you can iterate from left to right, and we just iterate from left to right in a sense that is a sweep line, right? And when you sweep, then now C is going to sweep the other, well, no, I mean, it doesn't matter which way it sweeps in any case, but in this case, it actually sweeps with the B, right? So it sweeps with the B, then you could do the count that way. So we'll try to do it that way. Yeah, and that's basically the idea that I'm going to have, right? So yeah, so maybe we do for I, A, and enumerate nums, right? Yeah, I don't like this. I don't like the way that way. And I know that this is less Pythonic, perhaps, but I like that there is more symmetry, right? I think that's why, because then now, you know, this is they're more like this pattern is more established, and readability. You know, this is a side thing, but people talk about readability and what makes good code / what makes code readable is that the first principle that I go by is the principle of least surprise, right? And then it could mean different things to different people, but if you write code that surprises you, that's not good code, right? Or that surprises other people, maybe, right? I mean, I guess if it surprises you, it's probably even worse. But if you surprise other people, is that's when that's why, and some part of that we go into symmetry, right? Like this symmetry in code, then it's less surprising, right? So if I wanted to write something like, and this is a little bit of a sidetrack, but if I write something like this, and then maybe I write something like, I don't know, I don't even know if I could do this quite well. I don't know if this is like, I don't remember the exact syntax for enumerate, or the parameters for enumerate. I think there's an offset, but maybe I'm wrong. Yeah, there's a start, but I think this is not quite right, because I think the start is more this is what this index starts at, and not starting from, I mean, I guess you could do it like something like that and then start from I+1, but then I don't know, this feels a little bit, just a little bit more awkward. Maybe you could get used to it, I don't know, but yeah, but I think for now maybe this is just keeping it dumb and simple, right? Oh, the other way around. Oops. right? So you have something like this, and then now you're trying to find C, right? And as we know, C, I don't know why you wasted, right? So that means that we can just in here find the number of C that is less than A plus B. And then here we can do, like I said, we start with a window, right? And maybe, I think we have to, well, the sweep is actually on the B. I mean, this is a little bit like, I don't know, if you're not following, this is a little bit weird. But basically, we want to say, the way that I think about this anyway, maybe, you could differ and play around with other things, is that in this iteration, I actually kind of conceptually hold A constant. So then we're sweeping on B, assuming A is a constant. And then as a result, now we have an invariant that we try to figure, which is that A plus B is greater than C after we do some magical thing, right? So maybe here we could say K is equal to the index 0, right? And then now we go, okay, well, K is less than N and num sub K is less than, let's keep it the same way, right? Or the other way, whoops. Well, if this is true, we increment by 1. And that means that the invariant here that we keep in here after the while loop, the invariant is that num sub K, well, is that K is either N, of course, right? This part is breaks out, or A plus B is less than or equal to num sub K, right? Which also means that the triangle inequality no longer holds, right? That's basically the idea. And then now, as a result, that means that this means indexes from 0 to K minus 1 are all possible answers or solutions, maybe, I don't know. So let's just say solutions, except A and B, or index I and J, right? So then now, and that's it, right? So we keep a global count because, I mean, you could keep a running count, it doesn't really matter. But yeah, then the idea here is that, yeah, so here maybe we write count how many numbers are from index from 0 to K plus 1. Well, there's K, so we just K, right? But we have to subtract out A and B, right? So if K is greater than or equal to I, then count decrement by 1. If K is greater than or equal to J, which, yeah, I mean, I guess one is a subset of the other, so you could write this a little bit differently. But yeah, but that's basically to subtract it out so you don't double count. Actually, I think I'm a little bit wrong on this one because here, I mean, it's true, but I think, but this does not define or maybe another way of saying is that this creates dupes, is what I mean, right? Which is not what we want, right? Yeah, because the idea, because the thing is that, I mean, it definitely does. I'm just trying to figure out a way to explain it. Because, for example, if you have 2, 2, 3, or 4, let's just make the example 1. You could say that A is equal to 2, B is equal to 2, C is equal to 3, right? So that's equal to, that's a part, let's actually just put it as a tuple, right? But then now, if you do this, right? Then now we also count, well, K is going to be greater than 4. So then now you take, that means that as 4, subtract the 2 and the 3, then now you count 2, 3, 2, which is a dupe of this, right? So that's basically what we try to avoid. And there's, the way to around it is not that hard. It's just that I didn't think about it. And the idea here is that we just have to define an absolute ordering, right? Yeah, we just have to define an absolute ordering, and you could maybe say that the ordering is A, B, and C in that order, right? Or or maybe A is less than, I mean, this part is already true because of the way that we did this part. It's just that we don't have the interaction about C. So we could do something like this. Technically, I guess this is equal to, and I guess this is also equal to. So as long as you keep this, is it like true? I think that's I think that's true enough. Yeah, I mean, okay. I mean, yeah. I'm just thinking about like the tie breaking things of like, for example, if you have like a lot of twos, and then like, well, this is technically true, but it's not enough, right? Because we can just say, oh well, there are a lot of possibilities of twos, right? What is this, a twos? So it'll be a choose 3 even. But if you also define like an ordering where it is ai, maybe as a tuple, right, is less than bj ck, then now this is a complete ordering, right? And then now this means that you're not double counting anything because there's only you're counting it in a canonical way, and that's basically the idea. And then now the change now then, instead of that this means index our possible solutions, we actually want to say because C has to be strictly bigger than B, and K is, so then now this is actually just from J to K minus 1. That's it. It's a very simple change. And that means that now, how many numbers are from K minus 1 to J, or the other way around, J to K minus 1 inclusive? I don't know. Actually, I'm pretty bad about this one. So it should be this, I think. Or maybe I'm off by 1. But yeah, no. I'm actually just wrong here. I mean, the formula I think is actually right, but but this thing is wrong. It should be J plus 1 because you don't want to include J, right? So yeah, so then now this is going to be J plus 1. And I know that the ones cancel out because sometimes I leave it like this and then people are like, oh, the ones cancel out. Duh, Larry, don't you know how adding ones work? But sometimes I like leaving it like this so that it's clear what we're doing. And listen, computers are faster than me and you. Computers are also smarter. I actually don't know Python bytecode stuff honestly that well, but I know that like if you do it in C or whatever, it just optimizes the way. So like write code the way that you want it to understand, to be understood, right? And it's okay to have constants. And if you actually know how things work, then it gets optimized the way anyway. So you're not paying anything for it. It's not like the computer doesn't even do an extra operation, is what I'm trying to say. But anyway. Yeah, so anyway, I actually won this because apparently, okay, so I'm way wrong. Why am I wrong by that much? Okay, but anyway, but that's the general idea. We'll debug it, of course. But it's either that or maybe I misunderstood the problem. That'll be funny because I feel like some days I just do like a very, very long video and then I misunderstood it and then yeah. Did I do A, B, num sub K? Okay. That's actually, I mean, I, J, and K is fine. We could work that out, but that's actually. Right. Oh, K is outside the range. So K is N. 2 plus 2 is. No, I mean, this shouldn't. Because it's. Oh, I'm dumb. I mean, no, but it still doesn't work. But I had it in my head to sort it in the beginning, but I think I just missed talking about it. But yeah. Otherwise, the sweep line doesn't work. But I think I was trying to talk about a sweep and then work my way back to talking about now you need a structure. But I just forgot. Look, again, it is 3:14 a.m. Pi a.m. if you will. So so yeah. Okay. I mean, it's still. I mean, yeah. I mean, this goes overboard, so it's fine. But I think at least this one is more correct. Okay. So it's 2, 2, you have 4. There's only one pair, right? So maybe I am off by 1 in either case. Because this is 3, right? So that means that k, well, k is the number. Oh, it's not. Oh, it's k minus 1 inclusive. So why do I start from k? Huh. Yeah, why? That is a little bit weird, actually. And again, we don't care about the constants. Okay. I don't know why. I mean, I don't know. I think I'm just too used to starting things from k or whatever that I just kind of subconsciously do it. Because I even wrote out k minus 1 because we're not supposed, because k is the number that is the next number, right? I don't know why I did it that way. But yeah, as you can see, like, I don't care about these constants, and it is intentionally so. Stop writing to me in the comments, please. All right, let's give it a quick submit. And let's get back to solving problems. I mean, I just didn't consider. I mean, yeah, I mean, this is a very easy case to debug. I just didn't consider it. I didn't consider zeros as possible inputs, to be honest. That's wild. I mean, I didn't expect zeros to be in the input, but I also thought it would still work. I mean, clearly the idea. No. I mean, the short answer is that we just do something like this, right? But that's crazy, though. Because k minus 1. Oh, yeah, no, I see. So, yeah, no, it's the 0 case. Because even if they were all ones, because I was trying to figure out why I thought it was the n minus 2 case, or n is equal to 2 case. But I think even without this, it should work. Hang on, let me change it back. But I just didn't see that the inputs could be 0. In fact, I guess you could just remove the zeros, really. But yeah, you could see that this works because k would still get moved. But the reason why this doesn't work with zeros is because it actually doesn't get moved past, because the assumption here is that k is greater than, yeah, by definition, if everything is positive, this would make it so that k is greater than or equal to j, which would make this fine. But but this does no longer true if nums are 0. But we should also just filter it out, because no possible and like, we could do it the other way, but I feel like no possible answers contain zeros, right? So maybe we yeah, maybe we can just write something like nums is equal to x for x in nums if x is greater than 0. There are no negative numbers, right? But I mean, I guess this would also filter out the negative numbers in either case. So yeah, so this is more precise. Hopefully this isn't wrong. Okay. So apparently I did one silly mistake last time too. Was it the same one? Curses. Except for it has 3 things. What did I even do last time? I mean, I did the prefix thing. Oh, this is actually way more complicated the last time I did it with the frequency thing. Which this, I assume it works based on the fact that num sub I goes up to 1,000. But I don't know. I think this one is more cleaner and obviously does not actually take advantage of the fact that it's 1,000. It's just n square. Is the other one faster? I mean, is that at least n log n? No, it's still n squared, so it's not faster. I don't know. Yeah, and that's it. That's all I have for this one. This is n squared, right? I mean, there is sorting, but n log n gets dominated by n squared. There is a while loop, but keeping in mind that k can only be incremented n times per j loop, or per I loop, maybe that's the cleaner. Like for every I iteration, k can only go from 0 to n, right? Here, right? In parallel with j. So it is going to be n squared, despite how maybe awkward it looks to the untrained eye. But yeah, it is n squared, and that's it. That's all I have for this one. Let me know what you think. Thanks for watching. I'm passing out. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.